Welcome back, everybody. Today's topic, we're going to be learning about measuring earthquake strength. And we're going to focus specifically on two scales today, the modified Mercalli scale and the Richter scale. Now, the first, the modified Mercalli scale, this is used to describe the earthquake in terms of the amount of damage it's done. It ranges from Roman numeral 1 all the way up to Roman numeral 12. And the modified Mercalli scale, I think, is a very simple scale to understand because it's personal observations of things that have been damaged during an earthquake. And you can compare it to the scale. You'll see it in a little bit when I get to it. Now, the Richter scale, on the other hand, this is a much more scientific scale. It uses instruments. It's used to describe the amount of energy released by an earthquake. It ranges from 0 pretty much to infinity. However, we do see limits on the Earth with the Richter scale. And each number increase indicates a release of 32 times more energy, and that's because it's a logarithmic type scale. Okay, back to the modified Mercalli scale. Here you can see, this is just the first half of the scale, how microquakes are really not felt except by very few people. A light earthquake here, felt indoors by many, outdoors by a few. A strong earthquake damages slight and specially designed structures, however considerable damage in ordinary substantial buildings with partial collapse. So you see how it's actual observations, and very specific actual observations. That's why I think this is a really nice scale to use. Obviously it's not as scientific as the Richter scale. Objects thrown into the air with the major to the great earthquakes. So very powerful earthquakes. And you can see on the right hand side they do have kind of like a comparison, an equivalent of the Richter scale numbers. Now, this is one way to determine the Richter scale. So for those of you who've heard of the Richter scale before, this could be one of the ways that it was used to determine. We all know up here our seismogram. We've been studying this in different areas, like in lab class, for instance. And we see the P wave and the S wave. And the way that this particular chart uses the Richter scale to measure the earthquake's magnitude is by looking at how high the highest S wave traveled above the midline. So there's the midline there. And the S wave peaked at about 23 millimeters above that line. Now, the other thing that we need to know is how much time lapses between the first P wave arrival and the first S wave arrival. And so if you have that time difference, which we're used to calculating because we're using that in earthquake epicenters, that's the other piece of information. In this case, it's 24 seconds. And the way this works out is we go to the 24 seconds over here, and we go to the 23 millimeter amplitude over here, and we simply draw a straight line between them. And wherever that straight line crosses the magnitude line, that's our magnitude earthquake. So in this case, it's a 5 magnitude on the Richter scale. Now you can see what would happen if we varied some of these numbers. For instance, if the amplitude number were much larger, say 100, and the distance stayed the same, which is, the distance is really what this S minus P is talking about, because that's what that information is good for, finding out the lag time. But let's say it was 100 and the distance was still 23 seconds or 24 seconds. We connected. We can see that the Richter scale number is going to go up to maybe 5.6 or 5.7. Now, the other scenario is we could have a different time difference. Let's say the time difference was only 4 seconds. The S minus P was they were very close together. And our number was still 23 millimeters for our amplitude. See, when you connect, you get something like a 3.8 magnitude on the Richter scale. So hopefully you see how this thing works now. It's all dependent on two numbers, the time difference between the S and the P wave, and the amplitude of the S wave above the midline on a seismogram. Okay, moving on. This is just a graphic representation of the Richter scale. I think it's a great one. I pulled it off the web, and you can see here how the magnitude numbers on the x-axis increase, and it stops around 9. We don't really see many earthquakes on Earth that are at 9. There have been a few, and then you can see as the energy increases, like the great earthquakes, like the San Francisco, the New Madrid earthquake, the Alaska earthquake, and of course the one we had just a few years back in 2004. That was a very large earthquake, and also the one that caused the tsunami in Japan, very large earthquake. But you can see how the graph increases exponentially. That's why that scale shows that each number increases 32 times more energy released by the earthquake. Okay, moving on. Damage. Ooh, that would be not fun for the librarian. Most people in earthquakes are killed by falling debris or collapsed buildings. That's the thing that really is the danger for earthquakes, is inside of a building or near a building that's tall and that's going to perhaps fall on you. So if an earthquake occurs and you're near an exit, try to get outside. If not, then you have to take shelter under whatever you can that you think could protect you from anything above you. Now, if an earthquake occurs in the ocean, energy is also released through the ocean water, and when it reaches the coastline of a continent or island, it may form a large, very fast-moving wave, and this is called a seismic sea wave or a tsunami. Tsunamis in the open ocean, when they're unrestricted from feeling the bottom, can move up to 500 miles per hour. They move like the speed of a jet airliner, and when they approach the shore and they start to feel the bottom and build up height, they can actually reach heights up to 150 feet. And most of the evidence for these really high heights doesn't exist because the people who could have videoed this aren't around to do so or to show us. And I do have some videos from the Indonesian tsunami and from the tsunami in Japan that I'd like to show you after this lesson. Let's stop and do that now.